Water is essential to life. It was the solution in which the first life forms were forged, nothing but small packets of membrane-bound RNA emerging in the deep sea, and since then has become a vital element in the myriad of chemical reactions required for life, such as photosynthesis, which provides the oxygen we breathe. From the lush Amazon rainforest to the Arctic tundra, water plays a crucial role in supporting the ecological processes of life and growth. The audio clip that resonated with me the most in regard to this reflection was the sound of ice melting on the Spree River, which runs through northeastern Germany, rising from headwaters in the Lusatian Mountains and flowing into the Havel River in Berlin. In the clip, you can hear the flow of the water as it tumbles over the stones in the riverbed. You can imagine how time has worn away the rocks and swept away minerals and nutrients into the river's various currents and eddies. You also hear the crackling and trickling that arises as the ice slowly melts and flows downstream, releasing gases into the atmosphere and carrying the particles downriver. The audio clip paints a picture of a river ecosystem, which supports life within the river and in the surrounding forest community, and contributes to the cycling of energy and nutrients as the icy water eventually flows into the sea. One of the organisms which exemplifies the importance of the river ecosystem is the Atlantic salmon. The Atlantic salmon is an anadromous fish, spawning in fresh water before migrating to the sea and returning to breathe and complete the cycle. The life of the salmon highlights ecological processes and interactions, such as predation and food webs, age structure, and nutrient cycling. Their life cycle begins when ova hatch in the freshwater lakes, destined to eventually enter the North Atlantic Ocean. Juvenile alevins sustain themselves off yolk sacs until they can brave the journey to the surface, where they are first exposed to predators, to gulp air to fill their swim bladders. The juveniles, now called fry, begin to feed on small invertebrates. Their presence is an indicator of a healthy ecosystem, as they're extremely sensitive to changes in water quality and climate. They are extremely vulnerable to environmental stochasticity and are therefore largely density independent. Anthropogenic influences such as agriculture and excessive CO2 use will induce changes in temperature and salinity, have the potential to wreak havoc on these organisms. By autumn, the fry have developed into parr and have undergone transformations as they begin the journey to the ocean. They become larger, and their internal mechanisms for regulating salt and water uptake change into those more suited to a life in salt water. These physiological and structural changes are driven by natural changes in abiotic factors, such as temperature and salinity of the water. By the spring, the parr have become smolts, and have finally reached the Atlantic, where they begin to feed on larger fish, such as herring and sand eels. These salmon are now fully adapted to survive and predate in salt water. After a few years, the Atlantic salmon reach maturity and need to reproduce. They use Earth's magnetic fields, the chemical composition of their home river, and long-lasting pheromones to find their way back upriver to their spawning grounds. Human impact plays a large role in this journey. Adult salmon have to find their way past fishermen, poachers, and navigate through large dams to reach the freshwater rivers and lakes where they can spawn. Once they spawn, the salmon, now referred to as kelts, head back towards the ocean. They are weak, as their bodies are adapted to salt water and they can no longer feed in fresh water. They are more susceptible to disease and predation, such as by bears, which are known to stand in streams and catch salmon during their seasonal runs. When the kelt eventually dies and is consumed, its nutrients and energy are passed to other trophic levels or returned to the rivers, lakes, and seas where they continue to benefit life in the ecosystem. Throughout their life cycle, the habitat and diet of salmon change drastically. This contributes to the cycling of organic matter and nutrients throughout trophic levels and environments. They also pass through very distinct life stages, defined by different characteristics and environmental impacts. Changes in the distribution and abundance of different age cohorts in response to environmental and anthropogenic changes will in turn impact the environment differently. Overall, the life cycle of the Atlantic salmon highlights the interconnectedness of different ecosystems around the world, from freshwater to saltwater and back again, and how changes to one aspect of an ecosystem have unforeseen ripple effects in others. The Indigenous peoples of Canada have long understood and respected the concept of interconnectedness. Everything from landforms and watersheds to little critters and beams of sunlight is a part of one big web. Everything needs to be respected and protected in order to preserve the entire ecosystem for generations to come. These values have been at the core of Indigenous practices for a millennia. The Mi'kmaq concept of Eduabdimuk, also known as two-eyed seeing, highlights the importance of viewing ecological problems through both the Western scientific and traditional Indigenous lenses. These viewpoints can supplement each other to ensure that ecological policies and applications are implemented strategically and in the best interest of everyone and everything worldwide. Especially today, with the looming climate crisis and environmental destruction from our ever-increasing population, it is essential to shape policies that will have a positive impact down the line. The key to this is incorporating the ideas of peoples who have long dedicated themselves to the preservation of this land and its indefinite continuity.